Now let's get into the multiplier effect. When autonomous expenditure increases, aggregate expenditure increases, and so does equilibrium expenditure and real GDP. An increase in real GDP is larger than the change in autonomous expenditure, as we can see as illustrated by the green arrows on the screen. We can see that if aggregate expenditure increases, so the curve shifts upwards, there's actually a greater increase in real GDP. The multiplier is the amount by which a change in autonomous expenditure is magnified to determine the change in equilibrium expenditure and real GDP. The initial increase in government expenditure or investment is followed by an increase in aggregate expenditure because it induces an increase in consumption expenditure. Let's think about this logically. If we have an increase in government expenditure in, let's say, parks and recreation or jobs or anything like that, people are going to get more jobs, for example. So if they get more jobs, they earn more money, and so if they earn more money, they spend more. So that's called an induced consumption. That increases consumption expenditure. But the magnitude of the increase in aggregate expenditure that results from an increase in autonomous expenditure, that's determined by the multiplier. The new aggregate expenditure function after an increase in autonomous spending is determined by adding the amount of the increase to every point on the graph. And so we just shift that curve upwards by the amount of the increase in autonomous expenditure. And the new point at which the aggregate expenditure function is equal to the 45-degree line is that new equilibrium point. The multiplier effect, as I mentioned, it tells us that the equilibrium expenditure increases by more than the increase in autonomous expenditure. As production increases due to a shortage, for example, of inventories with firms, real GDP increases. But with a higher level of real GDP, induced expenditure increases. Equilibrium expenditure increases by the sum of the autonomous expenditure and the increased induced expenditure. So, for example, if equilibrium increases by 200 and the initial autonomous spending was 50,000, 50, then the induced spending is calculated to be 150 because 150 plus 50 equals 200. And all this previous analysis applies even if there's a decrease in autonomous spending. Then we'll have induced decrease in consumption spending. So it applies both ways. When we calculate the multiplier, we're going to take a look at two separate cases. We're going to look at a closed economy and an open economy. So closed economy, I'll just reiterate this, is one that does not engage in international trade. And in this case, the multiplier gives the new quantity of real GDP at equilibrium. We're going to give the multiplier the variable k, and we're going to say that's equal to 1 over 1 minus the marginal propensity to consume. And if we think about this logically, we've already established that marginal propensity to consume plus marginal propensity to save is equal to 1. So it follows logically that 1 minus MPC is equal to MPS. So we can also say that the multiplier is equal to 1 over MPS. In an open economy, we're going to assume that MPC plus MPS plus MPM, or marginal propensity to consume, plus marginal propensity to save, plus marginal propensity to import is equal to 1. And again, an open economy does engage in international trade, so you do have to take into account the fact that people do buy imports. So not all of their spending is going to be counted as consumption. Some of it's going to be counted as imports. And so in this case, we're going to keep the same formula. We're going to say that 1 over 1 minus MPC is equal to the multiplier. But in this case, 1 minus MPC is equal to MPS, or marginal propensity to save, plus marginal propensity to import. So our second equation that we have is equal to 1 over marginal propensity to save plus marginal propensity to import. We're going to now take a look at how aggregate demand and aggregate expenditure interact with each other. When firms are unable to meet inventory targets and they increase production, they also increase price. And when they need to reduce inventory and reduce production, they reduce price to get rid of that inventory. I'll just touch on a couple of things that I've mentioned in previous lectures, just in case we forgot, because we might need this later on. The wealth effect it just states that the smaller the purchasing power of wealth, the less people spend and they save more. So with less wealth, people spend less and they save more. So thus, a higher the price level is, the lower is the aggregate expenditure. And a couple of substitution effects. For a given expected future rise in price level, a rise in the price level today makes current goods and services more expensive than in the future, so we purchase today instead of in the future. It's called intertemporal substitution. For a rise in domestic price level increases prices relative to foreign produced goods, domestic imports increases and exports decrease, and this is international substitution. If our goods that we produce in our country are more expensive, then we might as well just buy them from abroad where they're cheaper. When the price level rises, both these effects, the wealth effect and the substitution effects, reduce planned aggregate expenditure at each level of real GDP. So when the price level rises, the aggregate expenditure curve shifts downwards, and when the price level falls, the aggregate expenditure curve shifts upwards. When the price level changes, there's also a movement along the aggregate demand curve. And at each point on the aggregate demand curve, it corresponds to a point of equilibrium expenditure on the aggregate expenditure curve. Let's take a look at how this works graphically. So let's say that we have a decrease in the price level. Then we're actually going to have an increase in the aggregate expenditure curve, and that we can see is mapped on the graph above. And that aggregate demand curve corresponds to a point of equilibrium expenditure on the aggregate planned expenditure curve. In the same way, if we have a rise in the price level, then we're actually going to see a decrease in the aggregate expenditure curve. And so that corresponds again to a point of equilibrium on the aggregate demand curve. If we have a change in anything other than the price level, let's say we have something that increases aggregate demand in the short run. So when aggregate demand shifts as a result of an increase in autonomous spending, the amount of this increase depends on the multiplier. In the beginning, in the short run, we're going to assume that the price level stays the same. So we're still going to have an increase in aggregate expenditure because, again, it corresponds with the aggregate demand curve. So we have an upward shift of the aggregate expenditure curve because we're producing more real GDP at every given price level in this case. So the price level does rise eventually, and the aggregate expenditure curve must shift back downwards. And the new aggregate demand curve intersects short-run aggregate supply. I just want to mention this. The steeper the slope of the short-run aggregate supply, the larger is the increase in the price level, and the smaller is the multiplier effect on the real GDP. But an increase in the aggregate demand in the long run, it goes as follows. The price level will initially remain at the same, and aggregate expenditure will shift upwards. And when the price level changes, aggregate expenditure will shift back downwards, and short-run equilibrium is reached, as we just saw. But real GDP now exceeds potential GDP. So shortages of labor increase and the money wage rate increases. Higher money wage rate increases cost of production. The short-run aggregate supply curve shifts leftward, and the price level rises again. So aggregate expenditure will shift back to its original position, where real GDP equals potential GDP. When the money wage rate and the price level have increased by the same percentage, real GDP is again equal to potential GDP, and the economy returns to long-run equilibrium. The point here is that in the long run, the multiplier is equal to 0. Aggregate demand will shift back to where it originally was. And if you're a little confused by why this happens, I'll link a video right now on screen for a previous lecture that I've talked about how aggregate demand and short-run aggregate supply and long-run aggregate supply work, and how they interact, and why this happens the way it does. It'll make a little bit more sense if you watch that video. That was the series on expenditure multipliers.